morning, students. In continuation with the last class, lesson 1, class 10, chemical equations and reactions, we are going to continue. Today we are going to study about decomposition reaction. What is decomposition reaction? The reaction in which one compound decomposes in two or more compounds or elements is known as decomposition reaction. As you all know, the word decompose means to break. The word decompose means to break. So, when a compound breaks into two or more elements or two or more simple products, it is known as decomposition reaction. Common examples are when we heat calcium carbonate, CaCO3, it breaks up into CaO, that is quicklime, and carbon dioxide. There are three types of decomposition reaction. We'll study one by one. First is thermal decomposition, then electrolytic decomposition, and photolytic decomposition. First of all, we are going to study about thermal decomposition. The decomposition of a substance on heating is known as thermal decomposition. The decomposition of a substance on heating is termed as thermal decomposition. For example, we will study the decomposition reaction of ferrous sulfate crystals. As you all know, ferrous sulfate crystals are green in color, pale green in color. The formula is FeSO4.7H2O. FeSO4.7H2O. So, when we take some crystals of ferrous sulfate in a dry boiling test tube and heat it, what happens? These crystals decompose into ferric oxide, that is Fe2O3, sulfur dioxide SO2, and sulfur trioxide, that is SO3. The evolution of oxides of sulfur is identified with the characteristic order of burning sulfur. The equation, we can write the equation as 2FeSO4 on heating decomposes into Fe2O3 plus SO2 plus SO3. Here, another example is of lead nitrate, heating of lead nitrate. What do we do? Lead nitrate is an inorganic compound available in the laboratory as colorless crystals. The crystals of this lead nitrate, PbNO3 twice, is colorless. On heating, lead nitrate breaks into simple substances. On heating, lead nitrate breaks into simple substances. When these crystals are taken in a test tube and heated, what happens? First, we hear a crackling sound. Which indicates the decomposition reaction. Emission of brown fumes of nitrogen dioxide is observed and a yellow residue of lead oxide is left behind. You can see the reaction on the screen. 2PbNO3 whole twice. This is a white colorless crystals. On heating, they will form lead nitrate, that is 2PbO. 2PbO is yellow colored. Then evolution of nitrogen dioxide, 4NO2. Evolution of brown fumes of nitrogen dioxide, and oxygen is liberated. This decomposition reaction is carried out by heating. Therefore, it is known as thermal decomposition reaction. So, we have learned two examples of thermal decomposition: lead nitrate, then ferrous sulfate, calcium carbonate also. We can take calcium carbonate is also white color compound. If we heat it, calcium carbonate will break up into CaO and CO2. The next is electrolytic decomposition. Electrolytic decomposition. What is electrolytic decomposition? When a decomposition reaction is carried out with the help of electricity, it is known as electrolytic decomposition, or reaction in which compounds decompose into simple compounds because of passing electricity are known as electrolytic decomposition. This is known as electrolysis. A very common example is of decomposition of electrolysis of water. What we do, we take a glass container with two holes at its base. We set up an experiment of electrolysis of water. Then we put some water in it. We add some acid also, because acid makes it a good electrolyte. Then we pass electricity in it. Water breaks on passing electricity. Water breaks up into hydrogen and oxygen. See the reaction, twice H2O on passing electricity will break up into 2H2 plus O2. When electricity is passed through this acidified water, bubbles of gases are observed at both the electrodes. These gases are collected in the inverted test tubes, and the volume of gas collected on the negative electrode, the volume of gas collected on the negative electrode is double the volume of gas collected on the positive electrode, that is anode. The reaction is done with the help of electricity, so it is known as electrolytic decomposition. And during this electrolysis of water, we get two volumes of hydrogen and one volume of oxygen gas. This shows that water is made up of two parts of hydrogen and one part of oxygen. Two parts of hydrogen and one part of oxygen. Hence, the formula H2 is also verified. The third type of decomposition reaction is photodecomposition or photolysis. Photodecomposition or photolysis. So we can say reactions in which a compound decomposes because of sunlight. It is known as photolysis or photolytic decomposition. Example, when silver chloride is put in sunlight, it decomposes into silver metal and chlorine gas, 2AgCl. When it is exposed to sunlight, it breaks up into twice Ag plus Cl2. Twice Ag plus Cl2. This is photolytic decomposition. In the same way, when silver bromide is heated, it also decomposes in the same way, 2Ag plus Br2. So this is how decomposition reaction takes place: thermal decomposition, electrolytic decomposition, and photolytic decomposition. The third type of reaction is displacement reaction. Displacement reaction. What is a displacement reaction? See, the reaction in which a more reactive metal, the chemical reaction in which a more reactive element displaces a less reactive element from its compound, or we can say from its salt solution, is termed as displacement reaction. Displacement reactions are also known as substitution reactions or single displacement reaction. In general, a displacement reaction can be represented by using a chemical equation. A plus BC gives you AC plus B. This is showing that A is more reactive than B. If B is more reactive than A, then A will not be able to displace C from BC and the reaction will not take place. Common example is zinc plus hydrochloric acid. When zinc reacts with hydrochloric acid, it gives hydrogen gas and zinc chloride. Zinc, when reacted with copper sulfate solution, you know copper sulfate solution is a blue color solution. So we take a test tube, put some copper sulfate solution in it and add some zinc granules and keep the apparatus set up for 4 to 5 hours. After 4 to 5 hours, what do we see? That the blue color fades. That means zinc has displaced, zinc being more reactive than copper, has displaced copper from its salt solution and zinc sulfate is formed. This is showing that zinc has displaced copper from its solution. So this is displacement reaction. Again, I'm going to repeat. A reaction in which a more reactive element displaces a less reactive element from its compound or salt solution is known as displacement reaction. Displacement reaction is commonly used in finding out the reactivity of metals. It is widely used in finding the reactivity of metals. Then comes double displacement reaction. Double displacement reaction. What is a double displacement reactions? Reactions in which ions are exchanged between two reactants forming new compounds are called double displacement reactions. Or in a simple language, we can say the reaction in which two compounds react by an exchange of ions to form two new compounds is known as double displacement reaction. It is also known as ionic reaction or precipitation reaction. You can see on the screen AB plus CD gives you AC plus BD. When the solution of barium chloride, see this is a solution of barium chloride, is reacts with sodium sulfate Na2SO4, BaCl2 plus Na2SO4, what is formed? This Ba plus and SO4 minus. Ions have changed and twice Na plus and Cl minus, twice NaCl. It is also known as precipitation reaction because in this reaction, a precipitate is always formed. When sodium hydroxide, a base reacts with hydrochloric acid, sodium chloride and water are formed. Double displacement reaction in which precipitate is formed is known as precipitation reaction. And neutralization reactions are also examples of double displacement reaction. So, see, AgNO3, this is a precipitation reaction. Double displacement also we can say, precipitation also we can say, or ionic reaction also we can say. AgNO3, silver nitrate, when reacts with sodium chloride, NaCl, AgCNO3 plus NaCl, AgCl, that is silver chloride, precipitate of silver chloride is formed, and NaNO3, sodium, aqueous solution of sodium sulfate is formed. The last is oxidation and reduction reaction. Oxidation and reduction reaction. What is oxidation? Adding of oxygen or removal of hydrogen from a compound is known as oxidation reaction. Adding of oxygen or removal of hydrogen is termed as oxidation reaction. What is reduction reaction? Addition of hydrogen or removal of hydrogen. Addition of hydrogen or removal of oxygen is termed as reduction. Another term is there, oxidizing agent. See, what is oxidizing agent? The substance which gives or which supplies oxygen for oxidation is called as oxidizing agent. The substance which gives oxygen for oxidation is termed as oxidizing agent, or we can say the substance which removes hydrogen is also called oxidizing agent. In the same way, reducing agent, the substance which gives hydrogen for reduction is known as reducing agent. The substance which gives hydrogen for reduction is termed as reducing agent. The reaction in which oxidation and reduction both takes place simultaneously is termed as redox reaction. What is a redox reaction? A reaction in which both oxidation and reduction occur simultaneously is termed as redox reaction. Redox reaction. You can see this example, CuO, that is copper oxide when reacts with hydrogen H2, Cu plus H2O are formed. Here reduction, see, oxygen is removed from copper oxides, so copper is reduced and hydrogen is oxidized. In this reaction, copper oxide is changing into copper, oxygen is being removed from copper oxide. Removal of oxygen from a substance is called reduction. So copper oxide is reduced to copper. Copper oxide is reduced to copper. And same, in this reaction, hydrogen is changing into water, means oxygen is being added to hydrogen. So uh, hydrogen is oxidized. Addition of oxygen to a substance is called oxidation. So hydrogen is being oxidized. The substance which get oxidized is the reducing agent, and the substance which get reduced is the oxidizing agent. So copper oxide is the oxidizing agent and hydrogen is the reducing agent. I hope you have understood. We'll continue in the next class. Thank you and have a nice day.